We're going to continue with today's notes by talking about some strategies in working with proportions. So let's take a look at our first bell ringer. The ratio of boys to girls at Friendship Junior High is 5 to 6. What I'm going to do is make a little bit of some scratch work. I'm going to highlight that the ratio of boys to girls is 5 to 6. The next thing I'm going to do is substitute my known values. There are 490 boys, and we're looking for the number of girls. From here, I'm going to use my cross products to solve for the number of girls. To answer the question, there are 588 girls. Let's look at the next one. This question is a review from yesterday, so I'm just going to let you guys solve. X equals 7, so the side length of the square is 7. For the next problem, we need to set up the proportion and then solve to find LQ. So first, let's substitute all of our known values. MQ is 6 plus 15, or 21. MN is 6. We are looking for the value of LQ, so I'm going to call that X, and LP is 5. So here's the proportion we need to solve. Personally, I'm going to simplify that 21 over 6 before I solve, but you don't have to. I just prefer to have all of my fractions simplified. I like to keep the numbers as small as possible for as long as possible. And from here, we'll use cross products to solve. Again, you did not have to simplify the 21 over 6 in order to get to the correct answer of x equals 35 over 2. Now let's take a look at the notes. Today, we're going to focus on using the properties of proportions. Yesterday, we looked at the two big properties. Cross products, if you have a proportion, then you can rewrite it as a product. We also talked about reciprocal, where you can change the proportions into the reciprocals and they'll still be the same. We're going to look at two other properties today. One of those properties is rewriting the ratios as a comparison of numerators to denominators. So instead of A over B equals C over D, our first ratio will be the numerators, our second ratio will be the denominators. And our last property would be the reciprocal rule of the new rule. If if A over B equals C over D, then C over A equals D over B. Why are we making you rewrite these ratios and proportions in so many different ways? The reason is to really highlight that there's many correct ways to get to a correct answer. Let's take a look at our example 1. I'll let you read through the problem. In order to write the three equivalent proportions, I am going to label the diagram to see if I can find some patterns. Because I want my answer in feet, I'm going to convert all of my units to feet. So, to write three equivalent proportions, one pathway to a correct answer is to compare heights to bases. So the height of my yardstick compared to the base of the shadow, the height of my flagpole compared to the base of the shadow. Another comparison I could use would be from yardstick to flagpole. So the yardstick of 3 feet to flagpole, which is x, as compared to 12 to 36. My last comparison might be flagpole to yardstick. X over 3 equals 36 over 12. So these are just 3 different proportions that we could write in order to get to the correct answer. All 3 of these are legal. So pick a proportion and solve. I picked the first one. I tend to simplify my fractions before I move on. And the answer is the flagpole is 9 feet. Let's take a look at the next question. I'll give you a moment to read. I'm going to make my best effort at a sketch. We're comparing a model boat to an actual fishing boat. I'm not going to let my units bother me because, again, we're looking at ratios, and for the ratios, that unit situation will take care of itself. Let's look at 3 equivalent proportions. My first proportion just compares the width to the length of the model and the width of the length of the actual boat. My next proportion just uses the reciprocal, comparing the length to the width this time. And my last proportion compares widths to lengths. The purpose of writing the 3 equivalent proportions is not to confuse you. The purpose is to show you that there's more than one correct way to get to the correct answer. On a test or a quiz, you will not be asked to write 3 equivalent proportions for every problem. You'll just find one that makes sense to you and solve. So let's pick the one that makes the most sense to you and solve to find the width of the scale model. I picked the first proportion. After solving correctly, we find that the model should be 5.2 inches wide. Let's look at the last example. I'll give you a moment to set it up. And even though the length that we are looking for is GF, I am going to set this up like we did for our bell ringer and just focus on our given proportion. 8 over 20 equals 6 over CF. For my next 2 proportions, I'm just going to go back and use either the reciprocal rule or the exchanging or comparing of numerators and denominators, just to practice rewriting proportions. Again, it's not meant to confuse, it's just meant to give you practice in writing different proportions. From here, I'm going to pick my favorite proportion and solve. And I get that x equals 15. But keep in mind, we have not answered the question. X represents CF, not GF. So I need to do a little bit more work in order to find the answer of what GF is. And since the whole thing was 15, we knew that we've already used up 6. The remainder part of it will be 9. Now let's look at the last problem. I'll let you read over. Basically, we're going to be looking at some kind of an area problem. We are going to have to find a rate of area to time. Taking a look, I don't really want to mix my units, so I'm going to keep my time in terms of minutes. One hour and 24 minutes is 60 plus 24 minutes, or 84 minutes. And because we're going to be comparing areas, let's find the area of each of those walls. So now I'm going to set a proportion comparing my area to minutes ratio. So my area of 112 square feet compared to the 84 minutes is going to be equal to the area of 240 square feet to the time that I don't know. I'm going to simplify and solve. And the result of that unit conversion is 3 hours. So it will take 3 hours to paint the other wall. Okay, make sure that you have finished the notes, make sure you complete the exit slip, and then get the assignment that's due tomorrow.